So welcome back, everyone. When we left off, this 1937 Model A engine was, well, it was running, but not very well. Not very well indeed. In fact, it was running about as bad as I could imagine it to run. So what I want to do is do a little bit poking and prodding and see what the hell's going on. I ordered a tube of sealant. So we found that there might be a vacuum leak in the intake tube from here to here. And I'm going to roll with that as a possible culprit. So what I've got to do is we're going to remove this fuel line. We're going to replace this now. I have a new, I have some new fuel line material, all new fittings and everything, so that'll be fun. And we're going to replace that, but I'm going to pull the carburetor off, and I'm going to take a closer look at the jet situation and see if there's anything we can do to improve fuel flow through the carburetor. So we're going to put it under a magnifying glass, so to speak. Figure out what the hell's going on, because there's something going on with this carburetor. So let's take it off the engine. I picked up a tube of fuel resistant sealer. So that is an improvement over the ASIN sealer that I tried to use, which is designed for transmissions and engine cases, but it's not necessarily fuel resistant. So we're going to take the carburetor off, we're going to take this tube off, and we're going to remove the left sealant. Now, the way this was manufactured originally, there was no sealant needed. These fittings were, I believe, broached to a very tight seal. And, we don't really have the technology. See, the stuff never cured in the cylinder head. So, if that was a viable solution, it wouldn't have worked anyway. So let's get this out of my way. So where it stands, this engine will run. It'll start and run, just not very well. But it will run to an extent. And it just, you can't open the throttle. It doesn't want to take any more, it doesn't want to take on any throttle. It really is running quite poorly. So I expect a couple of things might be at play. Very poor fuel-air mixture. In other words, the design of the carburetor is such that there is nothing to, later carburetors had a spiral in the intake that would cause a little bit of a turbulent action to mix the air and the fuel more thoroughly. But what we have here is just a very simple Venturi system. I failed art class 12 years in a row, but I think you get the point. So, basic anatomy. We have our bowl. That's our float bowl there. We have the carburetor tube, the main body of the carburetor, and we have our choke, which is our choke. This little guy here is our carburetor body. Not shown in this picture is the needle valve. I'm going to try to explain this as best I can. So, air flows through here into the engine through a pipe. Okay. This is air and fuel mix here. And this is just air. Okay, so air flows through here and up. I believe they call that an updraft carburetor. I don't know. Here's our throttle plate. Throttle plate is actually in the wrong spot. It should be a little bit lower because this is our main jet. This is our only jet. This is the jet right here. How does this work? Well, so vacuum is created. And yes, the jet is before the throttle plate, not after the throttle plate. Does that make sense? So vacuum is created when the engine is spinning, and it's sucking the air through, which is through the venturi. This is a venturi, by the way. A venturi is where the airflow is slightly restricted, and it creates a burst of air, a burst of vacuum right above the venturi. This is a cross section, and it's that burst of vacuum that draws the fuel from the bowl through this port towards the bottom, but not at the very bottom of the bowl. So the very bottom is good for collecting sediment, and there's a little drain here. You can unscrew it and drain the fuel out. So the fuel flows under vacuum through this little tiny channel. Okay, you'll see these represent 3 little ports. Those 3 little ports is where my main confusion lies. Because those 3 little ports are drilled to a tiny port on the side of the carburetor body that is atmospheric air. It's this thing right here. Do you see it? A little brass screw right at the tip of my pen. So that tiny little brass screw, let's turn the light on. There we go. See it? That tiny little brass screw, that has a pinhole in it, and that pinhole is linked to these 3 tiny little ports. Now, it looks something like this. If you were to pull the carburetor apart, you've got, it looks like a thermometer. Okay? You get 3 ports here, 1, 2, 3. Now this is on the float bowl side. On the carburetor side, it looks more like this, or on the carburetor body, it looks like this. You just have that little port. That is basically the jet. That is this guy here, which fuel sprays out of, mixes with the air in the venturi, and goes into the engine that way as a mixture. This, when put together, corresponds to this point right here on our thermometer thingy. It's not a thermometer, it looks like one. Okay. Now, down here at the bottom, you have, and I'm going to do a little cutaway here. This guy right here is our thumb wheel. This is the mixture adjustment screw. And it's drilled sideways at an angle down this way to about this point here. This point right here connects to a port that's right about there. You can't really see it, but this port here is actually the fuel inlet port from the bowl. So the fuel flows through the bowl into this port where it is governed by the position of our needle valve. So this is our needle valve. Raise it or lower it to adjust the amount of fuel that's allowed to flow out of this port right here. That's the gateway. That's where fuel is introduced to the carburetor for the first time. The fuel then flows upward. It flows upward across these 3 little ports, where it is then sent through this port, which is this port here on the carburetor side. Does this make any sense? Where it is then introduced into the air path, where it becomes basically atomized fuel. Now, it took me, and I racked my brain. I can't find any literature, nothing on how this carburetor works and why it's built this way. And then it clicked. These ports, these 3 little pigs, are to introduce air into the fuel to atomize it a little bit more. I'm thinking, just a theory here, before it enters the throat of the carburetor, right here. It doesn't really make any sense to me why. I'm not really sure I'm right. I am not. I am not even sure that I'm right on this. And anybody who has worked on one of these carburetors who understands this design might be able to explain it a little bit better. But that's all I can come up with. It's got to be it. Anywho, I took the whole carburetor apart again, and I checked. I actually ran some solid wire through these ports to make sure nothing is blocked and there are no blockages. The ports are as clean as they're going to get. It's an old carburetor. It's possible that those ports might be out of spec. It's hard to tell. It's hard to say. But it is a distinct possibility that the carburetor is just way out of spec. But again, we've addressed two possible. So what I've done differently this time is I actually put some real torque on these screws on the carburetor body between this half and this half. These two here, these screws here, I torqued them a little bit more. Maybe there's a leak. Maybe there's a vacuum leak in this chamber. Now this chamber is only about actual size, about this big. And the thickness is only, it is like, oh gosh, it probably about that deep. So there's not a lot of nothing. Not a lot of yeah. So not much space there. I also cleaned out this channel a little bit better. The channel is, again, is probably only, hell, a 1/16 of an inch or less deep, maybe a 32nd of an inch deep, and that is the amount of space that the fuel is allowed to flow through. So I cleaned that up a little bit better. I ran wire through all of the ports to make sure that they were clean and free of debris. I took the needle valve out. I checked. I couldn't. You can't really see the needle valve seat. It's so far down in there, you can't really see it, and you can't get to it to clean it. So it's, you know. So now we're going to remount the carburetor. And this time, we're going to use a new product that I just learned about. This is a fuel-resistant gasket dressing and sealant compared to Hylamar Universal Blue. Let's give it a try. This is going to give us an airtight seal for the intake pipe, which is what do they call precision fit. In other words, it was never meant to be sealed, but you know, after nearly 80-90 years, things don't really work so good. Just like your grandpa's got plumbing problems. And that leads me to my next point. So I visited my local hardware store, like you're supposed to, you viewers, whenever you need hardware, especially weird things that you wouldn't normally find. You want to go ahead and visit your local hardware store because they generally know more about hardware than the pimply-faced kid at Lowe's. That's a generalization that is not hard and fast, so if you work at Lowe's and you just happen to be a be-pimpled teenager, this is no judgment on you. But on average, your local hardware store is going to have knowledgeable folks who know their way around a hardware store. Men and women both. We're not sexist here. In fact, come on. Some of the most knowledgeable hardware store folk I've met were actually women. So, don't be sexist. Okay. What's my point? Well, my point is this. I went to my local Ace Hardware. It's the helpful place. Remember that. And what I found was there is a point to all of this. So I went to my local Ace Hardware to get myself some 1/4-inch hose. I'm sorry, 1/4-inch copper lines pipe. The point I'm trying to make is this. I found that I just had an experience that was contrary to the expected experience of visiting my local friendly hardware store. And the gentleman who greeted me at the counter, I said, "Hey, Mr. Sir, I need some 1/4-inch copper tubing. And he said the question that I hate hearing because I've had similar experiences, especially with automotive stores, automotive parts stores. And he said, "What's it for?" And I said, "Well, if you must know, it's I'm making a fuel line." And he said, "Oh, you're not supposed to make fuel lines out of copper." And I said, "Yeah, but they did it 85 years ago, and I'm not going to change it now." Didn't really think I had to explain myself. And he says, "Oh, but you still shouldn't make," and he's telling me all the reasons why, because it's not good for your car, blah, 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 blah. And he said, "Well, sir, it's not for a car." He says, "Well, what's it for?" I said, "It's for a Briggs and Stratton engine." And he says, and he proceeds to tell me why Briggs and Stratton engines, like your car, don't require and should not have copper fuel lines. And I said, "Well, this engine was made 85 years ago." And he kind of shut up after that. But he kind of gave me an attitude, and I wasn't happy about that. But, you know, it's like I didn't come here to be berated on my decisions, my material choices here. I came here to buy some 1/4-inch copper tubing. I was none too pleased, but I just shut my mouth, and he eventually showed me. He was kind of upset. He's like, "I've never sold copper tubing before." I'm like, "Well, you must be new here." To which he said, "Yes, I am." Like, I couldn't tell. Anyway, that was kind of an interesting experience. Usually hardware stores are a little bit more, they pretty much let you buy whatever you need to buy and you get the hell out, you know. Usually they're a little more, but if you need help, they're always there to lend a smile and a helping hand. This was not one of those cases. He did eventually lighten up, and he found me what I was looking for, but I was still a bit taken by that experience. Like, "No, I know what I need. You just tell me where to find it. That's all." He found it. And he said, then he's like, "Oh, well, this box says it's for refrigeration." Well, I said, 1/4-inch copper line, or copper tubing is 1/4-inch copper tubing for the sake of this installation or application. So it's not a big deal. And he looks at me like I'm wrong. I'm like, "No, trust me, it'll work." It'll work. It's not, I don't need some magical tubing that's not rated for refrigeration. I think refrigeration tubing, I believe, has a thicker wall. That's the difference. I'm pretty sure that's the difference. But I don't care. I'm not here to discuss wall thickness. I'm here to buy some motherfucking copper tubing. Buddy, dude, just relax. Help me help myself. Help me find what I'm looking for. Anyway. So let's clean up the excess. We don't want this to look like it ended up in the wrong end of a Smurf. So here we go. I'll reconnect my spark plug lead. Now we have to make you guessed it, we have to make the fuel line. Okay, so for that, we're going to rotate the motor. Now, I don't have a brake tubing bender. Unfortunately, I just don't have one. So I bought 4 feet, by the way, in case I screw up, because I probably will. So I had to buy a tubing bender, and they only had one type at the Ace Hardware store. I mean, the helpful place. We're not shaming them. So this is, I've never used one of these. This is a, this unit slips over the tubing, and then you make your bend. So the principle here is these, it's basically a spring, and these rings prevent the tube from collapsing in on itself as you bend it. So let's see if that works. I'm going to bend it right here. Oh, it bends easily. Look at that. Look at that. Hey, Seamus, look, it bends so easy. Oh, yeah. I don't know why I'm doing this in an Irish accent. Okay. So I'm going to leave this like a service loop, or out, you know. And we're going to bend it in a little more to try to get it closer to the block. I might have to bend it a little more, and then we're going to bend it back in plane here. We want that kind of that offset. See what I'm saying? I want that little. This is. Let's try to straighten this shit out here. Make it a little less unwieldy. Okay, so that's going to go into the fuel separator like that. Look, it's going to come out nice and smooth bends. Okay, then we're gonna go like this. We're gonna bring our tool out, run it down the line here. Okay, it actually works out pretty slick. Then I'm gonna make a bend. I'm gonna go out. Okay, we're gonna go out. No, let's not do that. Let's just do it straight. Do a straight bend. Okay. Let me get a tubing cutter. This is ridiculous. I'm gonna cut a little bit off so I can maneuver this sucker. I'm gonna be wasting a little bit of line, but that's okay. It's not like copper is expensive or anything. But for those of you who are concerned about using copper as a fuel line, it's not a big deal. Copper is designed to carry water, refrigerant. I mean, it can carry fuel, oil. Oil lines for home heating systems, anyway, are made of copper. It's not a big deal. But no, you're not going to go out and buy a 2021 Toyota Camry off the line with copper fuel lines. That's not what you're going to get. You don't want to mix copper with other metals. Obviously, you don't want a copper line with steel fittings. That would be stupid. Brake lines are typically made of. You don't want copper brake lines. Anything hydraulic under high pressure. You don't want copper because copper is a very soft metal. Brake lines are typically made of steel, and as are fuel lines. So in this case, this is not a typical installation. The fuel line is not under pressure at all. It's not. I assure you, it is not under any amount of pressure. So, okay. So let's. Oh, this is all caught up in there. So let me just kind of dry fit this, see how this looks. That got bent there. And here, my tubing bender is getting all up in my way. Okay, this is all bent to shit, so let's straighten that out. Now this tubing is actually coated with a wax or some kind of a. You'll see the stuff burn off whenever you torch copper for soldering purposes. It's usually the first thing to burn off. Okay, so let's do this. We're going to cut it right about, because it's got a compression fitting, remember, so you got to make sure that you don't leave too much. So if I just kind of dry fit this where it's going to go, nice little bend on that. I like that. Give us a little bit of room to work with. So I'm going to just grab my marker. Here's a marker. And we're gonna really cut it right there. You want it to go, depending on how the fitting is made, you want it to go into the fitting a little bit, beyond the compression fitting. That's not something I read anywhere, that's just common sense, I think. But, and you don't cut it with a hacksaw, you use a tubing cutter. I don't know who's watching my videos. I don't know whether you've ever cut copper lines before or ever made copper flare fittings or anything like that. We're not doing flare fittings, but I don't know the scope of knowledge of all of my viewers, so I try to be very generic and I try to specify. So you just a little bit at a time, you don't tighten this thing down, you just get it snug on the pipe, roll it a few times. Snug, roll it. What this does is it gradually, the blade, which isn't very sharp, it just basically cuts into the metal a little bit at a time. And it works really well on copper because it's such a soft metal. But I've used these on steel brake lines too, and it works just fine. Okay. Of course. You can cut up to, it says 3 to 22 millimeters, 1/8 to 7/8 outer diameter. So that's what it can do. You can get these tubing cutters for a couple bucks at your local auto parts store, hardware store. Ace is the place for your tubing cutters. Okay. All right. You'll notice, all right, so the guy who cut this tube before me did it with, so let me show you something. This is actually kind of cool. So you'll see how on my cut, the inner diameter isn't really affected that much. But take a look at the hardware store clerk's cut. He used too much pressure. And what happens when you use too much pressure and you're cutting a soft metal like copper is it tends to roll in a little bit. And we can fix this, but we're really not gonna. You should actually ream this out with a, they actually have a reamer, but I'm gonna take a Phillips head screwdriver and I'm just gonna kind of stuff it in there and twist it around to undo the damage that my cutter did and to lessen the damage that the store's cutter did. Okay, let's get this pipe nice and formed in place here. Okay. Yeah. I'm going to have to bend this in a little bit. So I'm going to use my handy dandy pipe bender. What this does is it prevents it from ever kinking when you're bending it. A little bit at a time. There we go. Okay, that fits nicely. I'm going to have to kind of do an upward twist like that. Okay. That, my friends, is a nice, beautiful fueline. Okay, I bought new fittings because that's what you do when you're doing this. You never reuse the old ones. We've got new threaded fittings for both ends. Let me just make sure that they actually fit my my installation here. Make sure that, yeah, okay. So when you're dealing with, in the US, when you're dealing with NPT fittings, that's National Pipe Thread, I believe, or National Thread, Taper, whatever. When you're dealing with NPT fittings, everything is basically standardized. So you don't have to worry about, oh, will this fit or will it not? Because it will fit, but it's a one-shot deal. Once you crimp down on these compression fittings, that's it, Jack. That's why you want to buy extras in case you screw up. And I mean no disrespect to Jack. I don't know who Jack is, but it just seems to be a generic catch-all name for a random guy. I don't understand it either. The English language is such a funny thing. Okay. So I want to kind of thread this onto the carburetor. Gives me a headache here. Okay, it's coming in at too sharp of an angle, that's why. So what we need to do is we're going to take our handy dandy pipe bender, and we're going to give it a slight kink. Giggity. We're going to give it a slight upward kink so that tries to hit the carburetor at not such a steep angle. Let's see. Yeah, it needs to be a lot more than that. Okay, so let's do that again. All right, here we go. Okay. Here. We lost one of our fittings, but I still have it, so it's no big deal. So you want it to kind of go right in, straight into the fitting. Let me show you what I mean. So you want it to go right in straight, not kinked up or down, because you're going to have a bad time. So it takes a little bit of finessing. I mean, sometimes you need a little finesse, sometimes you need a lot. Why I remember that commercial, I will. You know what it is? My mom, actually not my mom, my babysitters watched a lot of daytime TV, and it was all commercials like that. Okay. Alright. You'll notice that my compression fitting stayed in the fitting. That's fine. Okay, let's get the other side matched up. So I want to share some unfortunate news that I had recently heard. I'm sure some of you have also heard. And I know this is a weird time to bring it up. I just feel like I have to say something. The world lost a celebrity the other day, 2 days. Was it yesterday or the day before? Somebody totally random. Most people don't know who she is. Her name was Conchata Ferrell. And very unfortunate. I never met her, but I saw her perform at a live taping of 2.5 Men, as I was actually in the audience for the season premiere 2013. It was filmed in August of 2013. This was after Charlie Sheen had left the show. And, yeah, so it was after Charlie Sheen left. And after Ashton Kutcher had joined the cast. So the cast that day, or for that taping, consisted of, what's his name? Alan. I forget Alan's real name. The actor who plays Alan. So it consisted of him, Ashton Kutcher, of course, Conchata Ferrell, who played the maid, or the housekeeper of 2.5 Men, and who else? Oh, Amber Tamblyn was the guest star that day, and I got to see I was at the live taping with a couple friends, just out, visiting California, and I made sure to, when I went out to California, I wanted to see a live taping of a sitcom, and it was the only one I could get tickets for, and I was actually a fan of the show too, so it kind of worked out, and wasn't a waste of time at all. I gotta bend it a little more. But anyway, so we got to see a live taping of that show, and Conchata Ferrell I always found her funny because her humor and her delivery is so deadpan and spot on. So anyway, I got to see how the actors interacted both on and off camera, and it's a little surprising sometimes, It's a little surprising how you don't really get to see that as an at-home TV viewer, You get to see, once the cameras are off, the actors' personalities, for better or for worse, tend to show up. And I can tell you that, and I'm sure he was just having a bad day, but Ashton Kutcher, my God, not a nice guy. He was just angry and pissed off. He had an attitude. Alright, so we're just buttoning things up. I just tightened the fittings on the new fuel line. You don't want to over tighten them because it's copper, it's soft metal, so go hog wild and gotta get the fuel tank bracket back together. I had to reposition the tank to make it easier to manipulate that copper line. That's okay. What do you mean? You're not supposed to use copper for a fuel line? Okay, Hank freaking Hill. Let me go my time machine, and I'm gonna punch out the engineer who first used copper for fuel lines, probably in the 1880s. But okay, yeah, we'll go with your theory, buddy. Okay. I don't know about you, but I'm kind of itching to see if this thing's gonna run or not. We're going to have to screw it back down to the table and put a little fuel in there. And I think I'm gonna put it in this way. I wanted to quickly address a concern that one of my viewers, and rightfully so, brought up. And I'm going to explain why this is not a concern. So one of my viewers had mentioned that I had to move the fuel line away from the block because it could suffer from a condition known as vapor lock, where the heat from the adjoining component or adjacent components will cause the fuel to basically vaporize in the fuel tank. I'm sorry, in the line. This is a serious problem in many automobiles over the years, especially carbureted ones, where the fuel from the heat of the engine will boil off in the float or in the lines. This is not an issue on this engine, and here's why. Number one, it was designed this way. The fuel line has always, on this generation of Briggs engine, the fuel lines always run this way by the block. The block does not get hot enough to generate the heat needed to cause that condition to occur. The other issue, or the other reason is, basically what it boils down to is that the fuel doesn't get hot enough in this configuration to ever burn off or to boil off or evaporate or whatever. It is not a concern at all. The one component in this region that would get remotely hot enough to cause a vapor lock condition is the exhaust pipe. The exhaust pipe is located directly above the fuel line, and I'm not really concerned about it, but it would be very easy to come to the conclusion that this could cause an issue where the fuel will basically boil off or vaporize before it ever reaches the carburetor. Or it pressurizes the fuel line with fuel vapor. That's, again, it's all relatively the same thing. Heat rises. So the heat from the exhaust pipe will rise above that fuel line, not go down to it. If the fuel line were routed above the exhaust, that would be another issue altogether. It would only become a problem if the engine were stopped. When the engine is running, there is airflow going through. It's actually getting sucked. I think how that impeller works is it sucks the air through the engine this way and then blows it out this way, and then it goes out here, and then goes up into the atmosphere. So the constant movement of air from the flywheel will not allow that to be an issue. But all the heat on a small engine is right up in here, right in this region here, and believe me, if this engine were designed in a way that would cause a problem, it wouldn't have made it out of the factory that way, or it wouldn't have been in production very long. And these engines were in production for a number of years. So I hope this helps understand why that is not an issue. The block does not get hot enough to cause vapor lock, even under heavy load. So, but thank you for the concern. Okay. well, I think it's time. I think it's time we try yet again to start this little engine. A little engine that could, but probably doesn't want to. So, let's give it a little persuasion. Okay, so let's do some checks. We got fuel in the tank. We've got oil in the crankcase. Plenty of oil, plenty of clean oil. Choke is on. Check. Fuel is on. I just turned it on. Okay. Let's see what's going to happen. And our sealer is good and tacky, so I think let's just give it a go. All right. So, how you doing? Nothing. Dick. Precisely dick. That's what we're getting out of this engine right now. Let's open the fuel a little bit more. Open the needle valve. Give it a crack. Open there. Nada. De nada. Okay, that's something. That's something, alright. Well, that's the best it's run as long as I've been alive. Use a little more fuel. Well, that's the best it's run so far. It hasn't run that good in a long ass time. Smoothly. We're going to give it a little more fuel. If that makes it any better or worse. No. So all we're doing is we're taking that needle valve and we're throwing it in one or two clicks at a time, and that's it. Put the throttle over. spray, which won't harm the paint or anything, and we're going to spray it around the carburetor to check for any vacuum leaks. I don't think that's a good issue at all. Alright, so we've had this engine running for almost a solid 45 minutes without any issues. It runs steadily. It's predictable now. It runs better than it ever did before, and I do credit some of the carburetor work I just did by just checking to make sure the jets were clear, retorquing the surface between the fuel bowl and the carburetor body. What else did I do? I also sealed the intake pipe a little better. I still suspect a bit of a vacuum leak, and I'm thinking I'm rolling around ideas on how I might fix that. One of the ideas I have is maybe to use lead solder. And what I would do is because it's the intake pipe, it's not going to melt solder. What I'm going to do is maybe coat it, like tin it in solder, and then use some emery cloth to fit it just right. Again, just rolling ideas. I'm not going to actually do that. Couple of other things. The front seal is leaking. Now, on an engine like this, you don't have a rubber or even a leather seal or even a rope seal. It depends on the oil to flow past the bearing just enough, and whatever oil drips past the bearing goes down into a channel where it drains back into the crankcase. It's a possibility there could be a blockage there, and that's actually highly likely. There could be a blockage in that drain back valve. There's one on either side. The back one doesn't seem to be leaking at all, but the front one definitely is. I want to drain the oil out, like I said earlier, and put fresh oil back in. I don't have any clean straight 30 oil to put in here. That's just what you do. Whenever you put an engine together, you definitely want to make sure that oil gets changed promptly. Because there could be dust and dirt and whatever else that could have been floating around in the crankcase that you didn't get could still be there. So I'm looking at the crankcase ventilator, and it's not covered in oil or anything, so that's good. That's doing its job. What else? So we have an oil leak in the front. We know that the only way to fix that would be to pull the flywheel and the stator cover back off and just check that valve to make sure it's not blocked. Okay, so we know that. It's not knocking. All I'm hearing is some valve noise, which I'm not really worried about that. These engines were noisy anyway, and it's 85 years old, so we're not going to worry about some valve noise. Compression seems to be holding pretty good. Seems to have gained compression. Let's do that. Let's do a quick compression test. We started out with about 62 pounds, and at this point in the game, let's see where we're at. Let's take a look and see what our compression numbers are. So this thing has had some time to break in. You know, it's really a heartwarming feeling that I just got this engine running. Let's see how she. Oh boy, she's burning rich. So we definitely need to look at that mixture. Yeah, she's burning a little rich. Just a little bit. Alright. Yeah. So that tells me that I can't seem to lean it out though. That's the funny thing. If I lean it out, it doesn't want to run. But it's running rich. Way too rich. Okay. See, look, it looks like it's covered in fuzz. Blacker than the Ace of Spades, and that's not oil. Now, if I were burning oil, I would know it. This engine would, you can smell burning oil. Burning oil has a very unique smell, and it produces a blue smoke. Most of you folks know that, but I'm just here to remind you. Burning oil is pretty obvious when it happens. So, let's do a compression test, shall we? Okay. Alright, screw it in. The accuracy of this gauge is in question. I bought this years ago, paid very little money for it. This is prior to Harbor Freight being in my area, so it was a while ago. So it was whatever the auto parts store had. So without touching the throttle, no, about the same, about 65. Oh, 65. 70, 65, 66, almost 70 pounds. So we haven't really lost, anything. We haven't gained anything either. Okay. So I got to talking this over with a friend of mine, and kind of doing some brainstorming, and we're thinking it might be an ignition problem. It could be weak spark brought on by weak magnets on the flywheel. And I like that theory. It almost makes sense. Because what's happening is when the engine, alright, it goes all the way down to how you know, an arc can jump from one conductor to the other under normal atmospheric pressure. It doesn't take very much. But what happens is when you increase the amount of the volume of air between those conductors, the electrodes of the spark plug, it becomes harder and harder for that gap or for that spark to jump from one point to the other because there's more air molecules for it to jump through. And effectively, when you increase the engine's speed by opening the throttle, for example, what's happening is you're introducing more air, and the engine's taking in more air, a higher volume of air, and it can't compress. It's compressing it, but it can't ignite because there's more air molecules for that spark to jump across. And what can cause that would be weak flywheel magnets, which I hadn't really thought about until yesterday. As far as it backfiring through the carburetor, what's happening here is there is a volume of uncombust fuel and air in the cylinder, and it's igniting it at the wrong time. So what's happening is let's try to start it. No, it hasn't started since yesterday, but let's just give it a try and see where we're at. So, turn the fuel on. Let's see what happens. The more air we bring into it, it's actually started right up. At low speed, it runs fine. There goes my theory. We're going to warm it up and then we're going to drain the oil out. then, folks. Sayonara. Well, that just happened. So I had this thing, you know, running and all, and then all of a sudden I hear something fall off the shelf, and I'm like, oh shit. And I just saw it out of the corner of my eye. It just missed the car by that much. It's that conduit box. Oh my god. That would have caused some damage. Son of a bitch. Green plug there. Yeah. Well, like I said. Oh yeah. Excuse me. Yeah, you can see it needed it. Look at that. There's probably about an hour and a half runtime total on that oil. Yeah. It's, change your oil, kids. That brings me to my next point. So, Briggs and Stratton is all for this fill for life shit with their engines. And I have one of those. I have an engine on my mower that's one of those Briggs motors with the fill for life nonsense. Anyway, one season of use. After one season of use, this fill for life, you never need to add. You never need to change the oil in your lawnmower anymore. The oil was worse than this. It was like carbon black with assembly lube mixed in. You can see that slight shininess to it. Brake-in oil, you know, that's what you're going to see, brake-in oil. But yeah, definitely not a thing. If you have a lawnmower engine with fill for life all over the side of it, you know, never need to change the oil, don't buy into the shit. Change your oil. Don't listen to them. They say you just need to check and add. No. No, not unless you want to replace your lawnmower in 3 to 5 years or less, depending on the size of your lawn. But look at that. Blacker than the ace of spades. But a lot of that is from running too rich and, you know, whatever else is. But I'm not going to refill this engine until I get some fresh straight 30. I don't have any on hand, so I got to pick some up. When I go out today, I'll do that. Look at that. What you got in there? It smells a little, it's a very faint combustion exhausty smell. But yeah, what you see there is, you know, what you see there is basically just oh, it's actually quite cold right now. Just the break-in particles from the rings, a little bit of carbon, and stuff that you know, probably ended up in the engine during reassembly, or you know, just in the process of that. What we don't see are chunks, which is a good thing. We could take a magnet maybe and stick it in there, but I don't think we got that problem. I don't think we're in that territory. But yeah, look at that. I'm gonna get rid of that. So this is going to be the conclusion of our video series of the Model A engine. We got it running. We tore it apart. We refinished everything. We got it running. There's a few more things I want to still do. Like I'm going to touch up right here, get my paint out, and I'm going to mask everything off, and I'm just going to paint the nose of this, just this section of the motor from all the fuel and shit that ended up on all over it. This engine runs pretty good for something that's been rotting behind a shed for 20 years. But that's it, guys. Thank you for watching, and I hope somebody's learned something from this. If nothing else, anything's possible. But Grandpa's old engine will live to see another day. I'm gonna build a little cart for it. Maybe put it up on a shelf. I'm thinking about just building a shelf right here and just sticking it up there. I almost caused severe damage to my car because I had stuff on the shelf that fell. Like, for example, this milk bottle hit the ground. Didn't break, but Amherst, New Hampshire. Sunway milk. Huh, nice. All right. Well, that's it, guys. Nice. Very nice.